my name is Lee Pound, and now we are looking at the Advanced Question on Unit 6 Quidio, which states, a researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this conducted in a greenhouse. From a large number of Roma tomato seeds, 24 are randomly chosen, and 2 are assigned to each of the 12 containers. One of the 2 seeds is randomly selected and treated with the additive. The other serves as a control. Both the seeds are then planted in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. The data were used to generate the partial computer output shown below. Graphical displays indicate that the assumptions of normality is not unreasonable. To solve this problem, we'll be using a method very similar to what we did in the basic problem called phantom. So again, we start with PR parameter. I defined mean of the control and mean of treatment, but the important one is the mean difference. The mean mu of D is the mean difference between the growth of the untreated and treated seeds in centimeters. So then we go to H, which is our hypothesis. So our HO, or null hypothesis, is that our mu of D is equal to 0, and our HA, or our alternate hypothesis, is that mu of D is not equal to 0. So from here we can move on to our assumptions. And again, we want to test randomization, normality, and independence. So the fact that it was a SRS was actually stated in the prompt. As for normality, they said that based on graphs, it is not unreasonable to assume normality. And then for independence, we have to assume that the sample size is less than 10% of the population. So in this case, 12 times 10 is less than the population of seeds. Next, we go to name the test. So in this case, we'll be using a one-sample t-test, and we'll be doing matched pairs. From there, we can move on to tests. The equation for a t-test is the sample mean minus the population mean over the sample standard deviation divided by your square root of your sample, or your number of sample. So if we plug these numbers in, which we get from the mini-tab shown in the prompt, we get a t-value of negative 5.997 or negative 6.0. Then we move on to O, which is obtain the p-value. So from there we take the t-value that we got and the degrees of freedom, and we use the chart in the back of our textbook, which gives us a p-value of less than 0.005 because negative 6 is way off our chart. From there we move on to M, which is make a decision, so we decide on an alpha value. For this problem, I chose 0.05, and now we're ready to make a statement. So from there we can say that we reject the HO, that the average difference in growth between the untreated and treated seeds is 0 centimeters because our p-value is less than 0.0005, which is much lower than our alpha value of 0.05. So we can say there is significant evidence against the null hypothesis.